Okay, now let's bring the third charge. So we start out with this configuration where the energy is UC is this value, and charge Q2 is at point P2, and charge Q1 is at point P1, and charge Q3 is at infinity. Now we go to the configuration where we bring charge Q3 from infinity and we put it at point P3. What will the energy in this configuration be? Called UD. So again, the hope we can do is to get the difference in energy between these configurations. UD minus UC.
This configuration is configuration C. It has energy UC. Charge Q1 is located at point P1. Charge Q2 is located at point P2. Charge Q3 is at infinity. This configuration is configuration D, and it's characterized by having charge Q1 here, charge Q2 here, and charge Q3 at point P3. So now the charges are finite distance apart, and the energy in this configuration is called UD.
So the difference in energy between the two different configurations is the work done by the external agent to move the charge Q3 from infinity to point P3 along some path. And we said that this is equal to the negative of the work due to the electric field, assuming the initial and final kinetic energy is the same. And the work due to the electric field is the integration of F on 3 dot dr. Now what's the force on charge 3 as it's moving along all this path? The force on charge 3 is Q3 times the electric field. The electric field is due to which charges? Well, now Q1 and Q2 are already there, and as Q3 becomes closer to them, both charges are going to make an electric field at the position of the path of charge Q3. So the electric field is actually due to Q1 and Q2. And so we can write it like this: Q3 times the electric field due to 1 and 2. Now this integration of E dot dr minus integration of E dot dr is just the potential difference between point P3 and infinity due to which charges? Due to charges 1 and 2. So we can use then the equation relating the energy difference in terms of potential difference. The potential difference is due to which charges? It's due to charges 1 and 2. And so we're getting the potential at point 3 minus the potential at infinity, which is 0 by convention, due to charges 1 and 2. Now what is the potential at a point in space due to two charges? We saw before how to get the potential at a point in space when you have many charges. You just add the potentials due to each. So that means we get the potential due to Q1 at point P3, which is KEQ1 over R13, and we get the potential at point 3 due to charge 2, which is KEQ2 over R23. You add these two, this gives you the total potential at point 3 due to both charges, compared to the potential at infinity, which is 0. So now we got the result that UD minus UC is this. Okay, so but we now know also that UC is not 0. UC has this value. So if you want to get UD, what would UD equal to? UD would equal to UC plus the two extra terms that we got. Now UC, we can just plug the value we got for UC over here. It's just Q2 times KEQ1 over R12. So this means that the energy in the configuration D is this old term that we had from before plus two new terms that we got due to the motion of charge Q3 from infinity to point P3. So this is the final conclusion, that the energy in this configuration was this value, and then the energy in this configuration is the old value plus an extra term due to the motion of bringing charge Q3 from infinity and putting it at point P3.